Hello, Math 7. Welcome back to another edition of our Math 7 screencast. We're on lesson 4 of Unit 9, talking about populations. So there's two types of population we're going to talk about today, box plots and dot plots. So here's a box plot. Basic things here. The minimum right here is 0. The maximum is 30. That looks like a 6. It's a 3. The range is the max minus the min. So 30 minus 0 is 30. First quartile, Q1 is right here. It's the beginning of the box. It's 5. And third quartile, or the upper quartile, is the end of the box, which is 20. The interquartile range is the top of the box, Q3, minus the bottom of the box, Q1. 20 minus 5 is 15. So what's the median? The median is always in the middle. Okay, it's actually the line that goes through the box, so it's 10. And it's saying on average, people exercise 10 times per month. Okay, and if I look at this data, notice how it's a little closer together at the beginning. So that means more people, right, are in the below 10. And then it's more spread out. So it's going to be hit or miss as to how many times over here. We have people exercising up to 30 days per month, which is pretty much every day, depending on the month. Okay, so when you compare two of them, right, you can look at the medians, right? This one has a higher average. Science class has a higher average of posted blogs. The ranges are the same, right? Max minus min are both 30. Here, the interquartile range is 10. Here, the interquartile range is 15. So that means it's more spread apart. The middle 50% is more spread apart. Okay, and the first 25% is really spread apart for science, 0 to 15. Okay, so that's basically how you compare the centers. All right, now let's look at this one. We have dot plots, and these are symmetrical. Notice it looks like a mirror image right down the middle. And what's nice about these is the median's easy to find. It's right in the middle. So here we have median of 81 versus 84. Now to find the quartiles, what you do in this case, right? The range is easy, right? 84 minus 78. But for the quartiles, you're going to kind of cross off till you get to the middle. And notice there's two numbers. When there's two numbers, you average them. 79 plus 80 divided by 2 is 79.5. And that dividing spot is right here. Same thing going up on the other side. Okay, we have two numbers again. So here it's 82.5. So our interquartile range is only 3. Our range is 6. And then you do the same thing for Lake City. So a couple observations about these graphs. Lake City has a higher average temperature, 84 versus 81. They have the same range. They have actually, do they have the same range? Let's double check that. It looks like they do. 82.5 versus 85.5. Yeah, they both have the same interquartile range. Now, Lake City, I think, it has the same range as well. So the only way you can compare these really is the average temperature, all right? 81 versus 84. Okay, you can't really look at the measures of variation, which are the interquartile range, the regular range, okay? Mean absolute deviation, we're not going to really touch on, but that's another type of another type of variation. Okay, so here you have non-symmetrical, but you do the same basic thing. You'd kind of count your way to the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16, so that means it's between, if I divide by 2, I get 8. So it's going to be between 8 and 9. So here's 8 over here. So that means your median is 35.5. Then for the lower half, half of 8 is 4, so it's going to be right in between 4 and 5. 1, 2, 3, 4, so it's going to be right here. And halfway between 4 and 5 up here is actually 36.5. So it's a little more difficult if it's not symmetrical, but you still do the same thing. You just count dots. Work your way to the middle, median. From the median, do not include the median. Go to the top, middle, Q3. Go to the bottom, middle, Q1, and subtract for interquartile range. Range is easy to see. It's 37 minus 32 here, and then you just make similar comparisons. All right, so here Pedro has a higher average versus Annika, but Annika's is more spread out. Okay, so that's how we compare populations. We're going to be talking about those two the box plot and the dot plots. Any questions? Talk to me in class, message me on Canvas, or send me an email. Talk to you soon. Do whatever it takes to dominate this lesson.